All right, besides linear regression, we also have exponential regression. So you're going to use the exponential regression feature on your calculator when you see one of two possible things. So first thing is this, if the scatter plot looks like a curve, looks more like a curve than a line, that's going to be an exponential regression. When the y values in the table get further and further apart, so they're not almost equidistant, like they're not almost the same space apart, they're bigger and bigger and bigger numbers. So those two examples look like this. This looks more like a curve than a straight line. So we would use exponential regression for this one. Or we've got ourselves a table here, but we've got 11 to 25, 25 to 48, 48 to 99. It's getting bigger and bigger. It's almost doubling each time, or even a little more than doubling each time. So that would be something where we would use exponential regression rather than a linear regression. All right, so the process of finding an exponential equation that best fits your data is extremely, very similar to doing a linear model. But I've outlined the steps for you just so we have all the steps in one place. So step one, we're going to enter our x and y data into L1 and L2, just like we do the linear model. The second thing we're going to do is hit the second button and get to the stats regression screen. Okay, again, just like we do the linear. This time though, instead of going to two variable statistics, we're going to scroll down till we see exp reg and then AB to the x. It looks just like this. It's option number 9 on the TI-36X Pro, and we're going to select that option. We're going to hit enter 5 times. Basically, we're going to keep hitting enter until we're telling the calculator to calculate the regression. And it's going to give you an A value and a B value. So we're going to use the A and B values to write the equation, and it's going to be f of x equals A times B to the x power. So we're going to plug in the A value where this A is, we're going to plug in the B value where this B is, and we're going to write it out. So if we use this one, now this table is the one that I gave you a second ago. If I use this in my calculator, I'm going to go to L1 and L2, and I've already entered the data. So 2 through 6, and then 11, 25, 48, 99, and 191. So there's all my data. So this is where I'm going to hit second, and then get to that stag rest. And so we get statistics and variation, all right, 1 variable statistics, 2 variable statistics, scroll on down linear regression, quadratic regression, cubic, power, exponential, reg, AB to the x power. That's the one I want because I think it's an exponential regression. And I'm going to hit enter, and I'm going to keep hitting enter until I'm telling it calculate. So that's 5 times. And I get an A value, I get a B value, and then I get that R value, which tells me really closely R equals 0.999. So this is an extremely close model of what it actually is. So I'm going to scroll back up to A and B. So I get that A equals 2.8. 2.8. I get that, and I just wrote that down. B equals 2.03, so I'm just going to put 2.03. And so that means that Y equals, I don't need these R values except to tell me that I'm really close, I'm on point as far as what the equation needs to be. So I'm going to plug these two in to this equation to get my equation. So the A goes first at 2.8 times, my B value is 2.03 to the X. So another way to write that would be 2.8 times 2.03 to the x power. Just a different way to write the multiplication. And that's it. That's my exponential regression.